All right, today we're going to take a look at 7.1, graphing exponential functions. All right, all of chapter 7 is going to be based on exponential functions and logarithmic functions. A lot of the material we're going to cover you may or may not have seen before. As we get further and further to the year, some of the stuff you might have seen kind of the basics, but generally, for the most part, a lot of this is going to be new. So we're going to be looking at graphing exponential growth and decay functions. So kind of how I like to start this unit out is just looking at this example. Some of you probably have seen it before. So your parents offer you to pay you 20 bucks a week. Yes, please. I will take that. Then you say, you know what, Mom, Dad, that's kind of a lot of money. I'll just take a penny this week. And then next week you can give me 2 pennies, and the third week give me 4 pennies. Okay. I don't want you to spend all that money on me. And your parents, who may not understand math, think that sounds like a really great idea. All right. So the question is, which is the better deal? Well, obviously in the short term, you guys can look at the completed notes here. I actually posted the entire table worked out. So at week 5, again, you have $20 from your parents, which would be a total of 100. At week 5, for the second option you proposed, you would be given 16 cents, which would have been a total of 31 cents. So still, your parents are kind of riding high right now. Like, this is a great deal for them. Week 10, you'd be given obviously $20 for a total of 200 on option A. With that second option, they would have to give you $5.12 for a total of $10.23 up to that point. So still a pretty good deal for your parents. Then if you notice, in option 12, it actually switches. Okay, option 12, it actually overtakes $20, and then it just balloons from there. So week 15, you would have $300 total you would have given or gotten from your parents, or received from your parents rather, not gotten. Option B, you would get $327.67. And then in the end, if we went all the way to week 20, 20 weeks, 20 bucks a piece is $400. That's option A. If your parents fell for it, went with option B, they would owe you $10,485.75. Okay. And that's basically the power of exponential growth. It starts really, really slow and it gets really, really high. This is kind of that whole idea of the rich get richer. Just because they have a lot of money, it grows slowly, and over time it increases exponentially. We have that same power and ability. If you start investing now, it grows slowly, but then towards your retirement, it will be quite massive, actually. All right. So we're just going to get into some basics here. You can see the general form of exponential functions on the bottom. Hopefully you see A, H, and K. Again, H is our horizontal movement left and right. K is our vertical movement up and down. A is going to be our general shape and orientation of our graph. Okay. So as we graph, the big thing to do today is create a table of values. All right. I always kind of like to hone in on that point. All right. Our H value, all right, is -3. I like to put that right in the middle of my table. Then I'm going to pick 2 points to the left, and I'm going to pick 2 points to the right. Then what I need to do is plug those in. If you'd like to use your calculator to help figure those out, you are welcome to. Otherwise, you can just do it mentally. 2 to the 0 is 1, or, yep, 2 to the 0, sorry. -3 plus 3 is 0. 2 to the 0 is 1. 1 times a half is 1/2. 1/2 minus 4 is -3 1/2. All right, we go the other way. -3 plus 2 is 1. 2 to the first is 2. 2 times a half is 1. 1 minus 4 is -3. If I plug in a -1, 2 squared is 4. 4 times a half is 2. 2 minus 4 is -2. And then if we go the other way, we're going to wind up with 3.75 and -3.875. Okay. So the question is, as we graph these, -5, -3.875, 75, 3.5, -2, -3, -1, -2. So it kind of looks like whoosh, that's our graph. All right. Again, we want 5 points. The reason I started with -3 in the middle was it relates directly to my H value. I picked 2 points to the left, 2 points to the right, plug them in to get that Y value. Okay. Some important things to kind of keep in mind here. All right. Our K value, if you notice, our points tend to level off to this -4 value. All right. So Y equals -4. Notice that's going to be the horizontal asymptote of my graph. Okay. Your value out front, A, is going to be your orientation and shape. If it's a positive value, it's going to go up exponentially. If it was a negative value, your graph would be flipped essentially over that asymptote, and it would exponentially increase away from that asymptote going down. Okay. So again, that's kind of the big thing. We want to pick 5 points graph. You should be able to figure out where your asymptote is. You should be able to plot your points. And I mean, you should be able to figure out your X and Y intercepts as well. Keep in mind, when we figure those out, to figure out a Y intercept, we would plug in 0 for X. So 2 cubed is 8. And then we'd actually get, there we go, 0, 0 is going to be our X and Y intercept in this case. So remember, to find your Y intercept, we plug in 0 for X. To find our X intercept, we plug in 0 for Y. And sometimes they don't exist. For instance, if my asymptote was above the X-axis, there would be no X intercept. All right. So kind of looking at an application here. All right. Our grandparents are starting a college fund for you. Awesome. That sounds really nice of them. They're going to deposit $5,000 into an account for you to use post-secondary. If they invested in a fund that yields 9% average growth, how much money will be in your fund in 18 years? So there's some important numbers to kind of keep in mind. We have our initial amount, 5,000, our rate of growth, and the time we're going to let it grow. Okay. Generally today, and kind of in the days ahead, we're going to use our general growth model, growth or decay. Okay. We're going to add our rate if it's growth. We're going to subtract our rate if it's decay. Okay. So in this instance, A is our principal amount, which in this case is 5,000. All right. We're going to add our rate. The important thing when we plug our rate into our formula, we always turn it from a percent to a decimal. And then T is always your time in years. All right. So we're going to let it grow for 18 years. After 18 years, we wind up with a fund that has $23,585. And since we're talking money, I'm going to round to the nearest penny, which is 60 cents. So that's a pretty sweet deal from your grandparents. They gave you $5,000. In 18 years, it turned to $23,585. You can imagine how if you had, you know, $500,000 to invest, what it would grow in 18 years. Okay. So hopefully you're kind of getting that idea in your head that if you start with a little, it can become a lot. If you start with a lot, it becomes a heck of a lot over time. That's the power of exponential growth. Decay is going to be the same thing, except our graph moves towards our asymptote. Keep in mind with exponential decay functions, the base is going to be between 0 and 1 instead of greater than 1. Okay. So we're going to do everything the exact same with these graphs. Our H value moves our graph left and right. Our K value moves our graph up and down. We want to figure out 5 points. We want to plot our graph, and we want to plot that horizontal asymptote as well. And again, we should be able to figure out our X and Y intercept by plugging 0 in for X to find the Y intercept and 0 in for Y to find that X intercept. All right. The last problem we're going to look at is problem involving my very nice 2019 Maserati, which I purchased for $107,400. You know, I just have money, you know, pouring out of my wallet. Just kidding. But this is my dream car. I would love to have one. So decay model, essentially same thing. All right, as before. So we have our principal amount. We have our rate, in this case, of decay. So it's losing 14% of its value each year. I want to find out in 2022 how much, you know, the value of my car is going to be. Okay. So we take a look at our standard growth model. So we have A1 plus or minus R to the T. In this case, my initial amount is 107,400. We're subtracting 14%, and we're looking at after 3 years, how much is the value of my car? Well, it dropped to $63,656.41. So hopefully at this point, if you don't know, but cars are actually a horrible investment. They lose value very, very quickly in, you know, consideration of thing as you drive it around. Okay. So yeah, kind of two life lessons. Start investing early, make your money grow over time, and then always try to buy a slightly used vehicle, because there's a lot of value that gets lost that first year of a vehicle's life. Okay. Just so you guys know, moving forward ahead with chapter 7, we're going to have problems in the textbook and a worksheet. Typically, the textbook assignment's pretty short. The worksheet kind of fills in some gaps we really want you to understand. Okay. So as you notice, there's a few problems out of the textbook and then the worksheet. Both are available. Both keys are available. If you have questions, feel free to ask me in class during our meet, whether you're in person or on the virtual, you know, classroom. Otherwise, you can also use the weekly discussion board as well to ask content-related questions, and I can answer them there for you. If you have any questions, let me know. Otherwise, the rest of the time is yours to work. Please make sure to come with questions as you have.